Right. I hope I'm audible. All right. We'll now start off with the next question. So the next question reads that the mole fraction of a solute is given as 0.1 at 298 Kelvin. Molarity of this solution is same its molality. Density of solution is 2 gram per centimeter cube. The ratio of the molecular weight of solute and solvent has been asked. So let's write the given of this question first. Alright, so in the question they have given you the mole fraction of solute as 0.1. Alright, molarity and molality. So let's assume that molarity is capital M and molality is small m, and they are both equal. And they have also given the density of solution as 2 gram per centimeter cube. Alright, now we need to understand that now we need to assume something to solve this question. So what needs to be assumed? Now let's so usually the trick is that whatever is given in the question, its denominator needs to be assumed as 1. Alright, so they have given you mole fraction of solution. So they have given you mole fraction of solution as 0.1, and mole fraction of solution is moles of solute divided by volume of solution. Pardon me. Moles of solute divided by moles fraction of solute plus moles of solvent. So this ratio has been given as 0.1. All right, now we need to assume what we need to assume. We need to assume that mole fraction of solute plus mole fraction of solvent is 1 basically. This is my assumption. So whatever is given in the question, its denominator needs to be assumed as 1. So given in the question is mole fraction, its denominator is moles of solute plus moles of solvent. So I have assumed the summation of these two entities as 1. So automatically moles of solute will be 0.1. Alright, now let's start. So moles of solute is 0.1. Moles of solute is 0.1. So I can directly say that moles of just give me a moment. Moles of solvent will be equal to 0.9. Alright, so we need to calculate molecular weight of solute upon solvent. Alright, chalo theek hai. So we'll consider molecular weight of solute as x and molecular weight of solvent as y. So we need to calculate x upon y. Alright, now so they have given you the molarity and the molality as equal. So molarity, so let's just say molarity is equal to moles of solute divided by volume of solution equal to molality. Molality is moles of solute divided by mass of solvent in kg basically. Alright, so this is what is the equation tells me, that molarity of the solution is equal to the molality of the solution. Okay, so obviously you can see that the moles of solute will get cancelled out, and we will be left out with volume of solution equal to mass of solvent. Alright, so in order to solve this part, we need to first calculate the volume of solution in terms of x and y, and then we need to calculate the mass of solvent in terms of, I guess it's already y because mass of solvent or molecular weight. Okay, so we need to calculate the mass of solvent in kg in terms of x and y and equate it. Alright, now let's start solving the question. So we have found that we need to make sure that these two entities are equal. Alright, so let's find out volume of solution first. So in order to calculate volume of solution, what we'll do is we'll calculate density. Density has been given. Density is mass of solution divided by volume of solution. So mass of solution is nothing but the total weight of the solution. So total weight will be weight of solute plus weight of solvent. So we already know the moles of solute and the moles of solvent, so I think it will be easier. So we'll do density is equal to weight upon volume, and density has been given as 2, and weight of the solution will be weight of solute plus weight of solvent. Okay, now let's calculate weight of solute directly. Weight of solute will be moles multiplied by molecular weight. So moles of solute is 0.1 multiplied by x, plus weight of solvent will be 0.9, because mole fraction is moles. So okay, wait, I think already we have established in the previous explanation that moles of solvent is 0.9 and moles of solute is 0.1. Alright, so let's continue with that solution. 0.1x plus 0.9y divided by volume of solution. So volume of solution, do we have the volume of solution? We need to calculate it actually. So volume of solution. Now we need to understand that the weight will be in grams and the volume we will get will be in ml. Why so? Because the density has been given in gram per ml. So gram and the gram here will get cancelled out, and the volume that you will get will be in ml. The volume will be 0.1x plus 0.9y by 2 in bracket. The unit will be in ml. So make sure that you get the unit correct as well. Alright, now let's look at the second part. We need to calculate the mass of solvent in this as well. So mass of solvent will be equal to okay, so mass of solvent we need to calculate. So mass of solvent will be basically moles of solvent, which is 0.9 multiplied by the molecular mass of solvent, which is y. So 0.1, this will be in grams. Alright, so let's now solve the question, because we have already received the equation earlier that mass of solvent in kg should be equal to volume of solution in liters. Alright, and we have both received one in ml and one in gram. So in order to convert this into kg, we'll divide it by 1000, and this into liters will convert it to 1000, and both if I equate these two equations, 1000 will get cancelled out. So I can directly write that 0.1x plus 0.9y by 2 will be equal to 0.9y. Alright, now let's find out x upon y. So 0.1x plus 0.9y will be equal to 1.8y. Let's further solve it. So 0.1x will be 0.9y. So x upon y will be 9. Alright. So it was probably an integer question. This was a previous year question of year 2016, as you can see. Okay, this was an integer question and the answer is 9.